Hi everyone. Today we'll be discussing about how to construct a right triangle when one side and hypotenuse is given. So for our example, let's say the sides given are AB is 5 centimeter and BC is 4 centimeter. Now we know that hypotenuse in a right triangle is the longest side. So AB must be the hypotenuse, whereas BC is one of the remaining two sides. And since we know it is a right triangle, we also have the knowledge that one angle would be 90 degrees. And so that angle would be the opposite of the hypotenuse. Now we know that hypotenuse is the longest side, so it's going to be AB is equal to 5 centimeter. And since A and B lie on the hypotenuse, then clearly angle C would be the one having 90 degrees. So angle C is equal to 90 degrees. And now let's make a rough sketch of how this triangle might look like. So let's take BC as the base and we create it as 4 centimeter here. And then we know that angle C is 90 degree. So let's just make a 90 degree angle here. And we don't know the length of this side. We don't know the dimension of this side. To get the dimension, we need to know both the points. One is this point and the other is where this vertex is. But right now we don't know where this vertex is. So let's just put it here somewhere. And we'll get to know where this vertex is using the hypotenuse. I know that hypotenuse length is 5 centimeter, so I can use my compass, fix it at 5 centimeter and create an arc and then connect the line such that it cuts at this vertex. So then we'll have both the information of A and C, right? And so that is what our approach is going to be like. First, we'll be creating the base of 4 centimeter. Then we'll make the angle 90 degrees and we'll just extend the line sufficiently long. Then to know where this point is there, right, then we'll take the help of this hypotenuse. So our extended line would be first created like this. We'll take a 90 degrees on this extended line and then with the help of hypotenuse, we'll see where it cuts on this extended line to get the whole triangle, right? Now let's see it in action. Let's put this somewhere and we also have the information here and let's see what our approach is going to be like. We discussed that our approach would simply be that first we'll take the given side as base and make 90 degrees on one of the vertex and then extend the line to get at which point there's a vertex to at which point the hypotenuse connects. We'll just take the length of hypotenuse and cut the extended line to get the new vertex and then we'll join the vertices. So take out your pencil, compass and scale and work this out with me. Construct the given side as base using pencil and scale. So we know our base is 4 centimeter and we have a reference figure right here. So we'll keep looking at it while we construct our figure. So we have our reference figure and now we have our pencil and scale. So let's make 4 centimeter side here. So that's 4 centimeter. We'll name it BC of 4 centimeter. And as you can see, we're talking about this side. So this side is done. Now what we need to do is we need to make a 90 degree angle here and create a big line here, create an extended line here because we don't know the length of this side. So we'll construct a right angle at one vertex and extend that line. To construct 90 degrees, we'll take out a compass and we'll put it on the vertex, right? And then we'll create a semicircle around here. Now from one endpoint, we'll just cut the same length, the same radius at this point, and this would give us a 60 degree angle, whereas we'll again in the same length, keeping the compass on the same length, we'll put it at this point and then we'll cut another arc right here. So this would give us 60 degrees, whereas this would be 120 degrees. So now if we take the middle of it, so that would be the average of 60 and 120, which is 90. So all we need to do now is keep the compass right here firstly, get an arc here and again keep the compass on 120 and get the intersection here. So this becomes the middle of 60 and 120. And then we'll connect this point to our vertex. And as you can see, 90 degrees is formed. And this is what we have, an extended line. That's why we've put it as dashed. It's not a solid line, means it's an extended line. All right. Now what we need to do is we need to construct that hypotenuse such that it cuts the extended line and tells us where this side is going to be. This is 90 degrees. And our third step is going to be cut an arc of length of hypotenuse on the extended line. Alright. So let's get our compass and scale back. We'll take our compass, create it at 5 centimeter. Then we'll put this on this vertex and try to create an arc such that it cuts this extended line. So it would be somewhere like this. And now, since we have this point at which this side is going to be, and at this vertex also, if we connect this point to this point, it will give us the hypotenuse. So we'll just have to join all the vertices, join the vertex to the cut arc to get the third vertex. So we'll join this vertex to this arc, and there we go. There we have the hypotenuse. We'll put it A, and we can see it is 5 centimeter because that is the length we fix the compass at. And since now we have this vertex A, all we need to know to get the third side is just we need to connect this, right? This A and C. So the length that we have now, this is the hypotenuse. So we again created another side of the triangle, and it is going to be this side. So we constructed this side, which is the hypotenuse. We constructed the base. Now we have both the vertices, both the endpoints of this side. So all we need to do is connect it to get the last side. And we'll connect it, and this is the last side too. So as you can see, this side is also taken care of. And finally, we get a right triangle, knowing only the length of one side and one hypotenuse. So that's all about it. Thank you.